Today I'm going to be going through the 2018 trial examination, and I'll be making a few corrections to some questions as I go, which is why I'm using Word rather than a PDF. So it's a 3-hour exam, 100 marks, so same as the HSC, same format as the HSC. So to start off with, the first question is, what is the correct hierarchy for waste management? Well, the first and most important is always going to be to reduce waste. Everything else is after that step. So that to me is the answer that I'm going to go with. Okay, so the next question here is, which of the following stress strain curves best represents a test result showing true stress and strain of mild steel? Okay, so because it's true stress, that means it needs to curve up. So these two are both true stresses. And for mild steel has a definite yield point. So this material here has a progressive yield point, whereas we can identify mild steel because it's got a progressive yield point. So it's going to be that one there. So A is going to be the correct answer for that one. Okay. So the next one is a Pascal's principle question. It says we have a diagram of a hydraulic system. What is the force of the output piston if the force of 20 newtons is applied to the input? Okay, so the difference between the two diameters, this diameter there's a diameter ratio of 2 to 1. So if there's a diameter ratio of 2 to 1, that means there's an area ratio of 4 to 1. So that means the velocity ratio is going to be 4 to 1. So if we've got 20 newtons in, that means we're going to get 80 newtons out. So D is correct. Okay. 4. Composites are widely used on structural components of aircraft, boats, and racing cars. What is the main reason for their use in their applications? Well, they're not necessarily easy to manufacture. That's a fairly detailed manufacture process. They're not necessarily cheaper. They have some impact. It's all relative when they say good impact resistance, but not compared to, say, steel. It's really their high strength to mass ratio. That's really the advantage. Now that could be with hyphens, strength to mass ratio, because it's an adjective, but yeah, why not? Okay. I worry that makes the question a little bit more obvious. It's already the longest question. Okay. Anyway, moving on. Which of the following testing methods is a non-destructive test? Okay, so tensile tests are where we stretch a piece of metal until it breaks. Transverse beam tests are where we take a beam and we bend it. Izod and Sharpie tests are both the toughness tests where we have a piece that we snap. Izod stands, Sharpie lies down. Rockwell hardness tests are where we use the machine, we put a small indentation in the side of the metal. That's considered to be non-destructive. If we have the Brunel hardness test, its predecessor, which uses a ball instead of a pyramid, that's considered destructive because it leaves a fairly large and noticeable ball-shaped mark on the steel. The Rockwell hardness test leaves only a small indent, and that's considered non-destructive. So the answer there is D. Okay. Question 6. Which of the following drawings shows a bolt in a threaded blind hole drawn to AS 1100 standard? Okay, so let's have a look. Well, that is threaded all the way through, which is not to say it's impossible. This section here is unlikely to be threaded, but it is possible. But it's gone. The thread has gone all the way down to the bottom of the hole. That's what that's showing. One big threaded bolt all the way down. This section here, this shows a tiny section. This shows no thread at all. It shows a shaft that's gone straight and then touching solid against the thread. So we've got teeth, and then we've got this bolt head just sitting on top of the teeth. That's what that's showing. Whereas this one here shows a bolt that's in partially threaded, and this section here with the lines there's nothing in here. So this part here is empty. We've got a threaded section up here, and then here we have a shank. So this one here, this doesn't really make any sense at all. This drawing just doesn't work. These lines don't make any sense. So that's what we're going with. Okay. Copper wire is 8 meters in length and has a cross-sectional area of 0.5 millimeters squared. Given this Young's modulus of 111 GPa, calculate the extension if if it experiences a tensile force of 300 newtons. So if it's got 300 newtons, what that means is, okay, we're going to use flea in this question. So E equals flea, so that's capital E equals capital E equals capital FL over lowercase e capital A for area. So we know, going in order, we know the capital E. So if we know the capital E, we're trying to find, in this case, the extension, calculate the extension in the y, so that's lowercase e. So if we're trying to find the lowercase e, we can just swap the two e's. So that means if we know f, so f in this case is 300, L is 8. Now we're going to use 8,000 millimeters because we want everything to be consistent, millimeters and megapascals. So we're going to go millimeters and megapascals. So 300 times 8 divided by, the area is already given. Often we have to convert from diameter to area, but not in this case. So 0.5, it's already in millimeters squared, so we're happy with that. Multiplied by E. So in this case, we're going with capital E, and it's 111 times 1,000 megapascals, because gigapascals is 1,000 times bigger. When you put all those numbers over into the equation, you're going to get the answer 43, which is that one there. Okay, in which of the following pairs do forces oppose each other in level flight? Well, let's have a look. So lift and drag, so they're going perpendicular to each other. They're not in opposite directions. Lift and thrust are also perpendicular to each other. Drag and thrust, they oppose each other. So the thrust is greater than the drag in order for it to actually be going forward and to be actually moving forward, but they're the ones that oppose each other. Weight and drag, so the weight and drag, they're perpendicular to each other, so they're not opposing. Okay. The diagram shows a universal I-beam with access holes drilled and supported and a supporting bracket fixed to each side. Which view shows the correct the beam shown in the direction of the arrows? So what we're looking at here is when we do a section, we've extended that center line here, so that center line all the way out, and we've called that section X. So it's like we sliced through that line and we're looking in the direction of the arrows. So if that happens, that means we're only cutting through a line here. We're cutting through a shape there. And we can see this webbing. So if we look at this one, so we want to have something where we're cutting through the eye. So that one's no good. The other three, we're all cutting through the eye. That's good. Now we're cutting through a hole. So that means we should see a blank where we're cutting through. So we're cutting through a hole here and we're cutting through a hole here. So that's good. So it's one of those two. And now we're not cutting through the webbing. So because we're not cutting through the webbing, that means that section should be shown as off in the distance, which is this one here. If we were cutting through the webbing, this one would still be wrong because there's a hole that we should be able to see. But there's no reason that this one could be right. So this one, D, could be right if we were looking at a section, if we were looking at this face. If we were looking earlier into the piece, where before, or ideally if we were looking at it after the hole, so a little bit further than the line X. So B is the correct answer. That's the best I can do. Oh, I don't want to move that. So, okay. So here we've got a bear in a box. We're pulling the box. So what value of P? Well, I would do my phony friction formula. For me, I mean, you can work it from first principles if you know F equals mu n, that the sum of the vertical forces have to be equal, the sum of the horizontal forces have to be equal. If you know those things, then you're probably right, but it's a lot faster if you just say, well, I've seen this before, this is a phony friction formula, and that's how I'm going to approach it. So in this situation, the first thing when we do our phony friction formulas, we need to know pH and PV. So because it's a 30-degree angle, we know that pH is going to be 86% of P. And we know that PV is going to be 50% of P. So we then write out a formula. 0.866 P, so 86% of P, equals mu, which is 0.4, brackets W, which is 230, plus or minus. Now in this case we're making the weight less. We're making the weight less, so it's going to be minus. So it's going to be 230 because we're multiplying by gravity. 230, so 23 times 10 is 230. 230 minus PV. And we've already said PV is half of P, or 0.5P. So when we multiply that out, just a second while I grab my notes. Okay, when we multiply that out, we're going to get, we're going to get 0.66p plus 0.2p, which we can simplify to 1.066p equals 92. So if we then divide 92 by 1.066, we get our answer. And our answer is A, 86.3 newtons. Okay, so this next question, what we're going to have to do is we're going to have to break our forces into components. We're going to have to break it into horizontal and vertical components. So same thing here, it's at 30 degrees. So if we know our 200 newtons, there are two ways of approaching this question. You could, if you were keen, you could find the angle of the line, the perpendicular distance from this turning point to here. You could do that. Too hard for me. So what I did is I just broke it into components. What I did is I said, okay, well, I know the horizontal component is going to be 86% of 200, which is 173. And I know the vertical component is going to be 100 newtons. So they're going in opposite directions. The 173 is going anti-clockwise, and the 100 is going clockwise. So I have 173 times 150, and that's going to be Newton millimeters. You could do it in, you could do your answers in, convert this into millimeters. That's probably going to give you the most correct answer. But if you, that's going to be going in this direction, and then you get a minus this one here, which is going to be 100 times 50. Now, because the answers are in Newton meters and not in Newton millimeters, what that means is that if you're going to use meters, don't be mistaken and say 0.5. This is not half a meter. This is 0.05. This is 5% of a meter, so 0.05 meters. That's the thing that gets a lot of people get wrong. So I just typed in, I just used the same units, but it's 173 times, 173 times 0.15 minus 100 times 0.05. And that will give you a 21 newtons. Okay, the next question, which graph, now this is a past HSC question, most of these are past HSC questions, so don't shoot the messenger if you disagree with this, but where it says is, I'll read the question, which graph best represents the relative proportions of materials used in the construction of new large passenger aircraft? Now, the two best examples of new large passenger aircraft are the Airbus A380 and the 787 Dreamliner. Now, they are both made of composites. So that's where we're going to, predominantly composites. So that's where we're going to go straight away. It's going to either be B or C because the composites are the big chunk. The next thing is, well, are we more likely, is the rest of the thing made out of steel or aluminium? It's more likely to be made out of aluminium, so that gives us B. 12, the answer is B. Okay, the orthogonal views of an object are shown. So when we look at these objects, three of them have this little lip. This one here has a groove along the side. Now, we don't have that little groove along the side. That doesn't exist. So it's either going to be A or B. B has a curve, whereas this one doesn't. So the answer is A. That was a pretty easy one. Okay, which of the reason I included that as that drawing is because I didn't include a isometric drawing in this exam. The reason I didn't include it is because the last 4 years there haven't been any meaningful isometric drawings, and because of that I'm concerned. Well, last year there was no marks for isometric drawings, and in the previous years there's been less and less isometric drawings which has concerned me, and as a result I didn't include an isometric drawing myself. I thought it's important to have something in there, so I included this question. Okay, now if we go through this question 14, this is 100 times 3. 100 times 3 is 300. So if we then divide that by 6, 300 divided by 6 is 50. X would need to be 50 in this situation. Okay, so here we've got 100 times 1 is 100, whereas here, so 100 divided by 3, well, that's 33. 33 is less than 50, so we can ignore A. A is out of the picture. Okay, here we've got 300 again. 300 divided by 4 is 125. C is out of the picture. B is still less. Okay, finally D, we have 300 again. 300 divided by 3 is 100, so B is still less at 33 and a third is still less than 100. Okay, so the answer there is B. Question 15. Okay, so we've got a logic gate it's a logic gate question. So what we're going to look at is, if we just look at this first question, I think it's a good idea just to progress A to D, and then once we have information from that, we know where to proceed. So first of all, if we close this switch so that the light switch is on, or so that these two switches are on, this is a NAND gate. Sorry, a NOR gate. A NOR gate. So that means if it was an OR gate, that would say if either of them are on, the whole thing is on. So in this case, they're both on. So because they're both on, that means this thing's on. The NOR gate flips it, and now that's off. Okay, so we have an AND gate, and the AND gate says, well, these both need to be on to turn the lamp on. So this one's already on. Where if we have both of these off, we get something that's on. So this one's off. We have on and off. On and off is not enough for it to go on. So on and off, they both need to be on. We only have one on, off. It's only 1 out of 2. If we close this one now, if we leave this one closed, we'd now have on, and that would be enough. So if we go off, off, on, let's look for off, off, on is C. Okay. This question, I don't like this question very much. I've had it in the last 2 years, but I think, anyway, there are different. Okay, so let's have a look at it. So first of all, it says a heat sink. It's past HSC question, so I didn't make it up, but a heat sink is shown used to conduct. The heat sink shown is used to conduct heat away from the components. Which row of the table identifies a suitable material and manufacturing process for the heatsink? Now, I wanted to have something that was a manufacturing process. I couldn't fit in a question on injection molding. I really wanted to have that, but I couldn't. So let's have a look. Well, first of all, it's a heat sink. So it's unlikely to be a ceramic because they're poor. A heatsink needs to be a good thermal conductor, right? So it can draw the heat away from the object. So it's really going to be steel or aluminium. It's not going to be plastic or ceramic. Now, is that rolled? Rolling is good for long sections, right? That's not a long section, or it's these shapes here obviously have come out that way, not this way. Or if they were to, you wouldn't roll that shape. You might extrude that shape, but you're never going to roll that shape. Rolling is for like long things like steel beams or railway legs, something like that. Now, so it's not going to be rolling, it's going to be die casting, and so that gives us our answer, aluminium alloy die casting. Okay, so 7, it says a metal plate 4 mil thick has an ultimate shear stress of 600 megapascals. A hole is punched through the plate as shown. What is the force required to punch the hole? Now, there's two kinds of questions here when we're talking about shear. When we talk about things like bolts, so in this case, when we're punching, what we're looking at is the ribbon area, right? The ribbon area is that shaded gray area. That's the area we're interested in. To do that, we find the perimeter, and we multiply the perimeter by the thickness. So if I go to my answers, okay. So the area equals 10 pi plus 20 all multiplied by 4. So 10 pi plus 20 all multiplied by 4, I got 205.6. Then we do, we're trying to find the force. So we know stress equals force over area. That means that force equals area times stress. So force is going to equal 206 times 600. So 206 times 600, and that's going to give us an answer in newtons, is 123,400. Our answers that we can choose from are in kilonewtons, so it's going to be 123.4. Okay, question 18. The drawing represents a loaded steel beam simply supported at each end. So what we have here is a uniformly distributed load, a UDL. Which diagram best represents the distribution of the shear forces along the beam? Well, in this situation, right, we know that there's going to have to be a diagonal because there's each of these little forces forcing the shear force diagram down all the way along. So it can't be this one because it doesn't have the little forces all the way along. And it's not going to be this one because that would have to require some sort of triangular forces, things that we haven't done. That might be the bending moment diagram for this object. Might be, but I don't think so. But the other thing is we can see these big drops here. So we have big drops here. So it's but it's not really. It's not really what we're looking for. So what we've got is let's have a look. We've got force up 5, going down a little bit, then down 3, then down, 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 down. That's all those little arrows here. These little curves. They represent little tiny arrows. So we're going up 5, down little bits, then we're going down in one big shock 3, then down little bits, down little bits, down little bits, then down in one big shot 7, then down little bits, down little bits, down little bits, then up 9. So that's what we got there. So these other ones, they're not correct. Okay, question 19. Again, I need my notes. So our formula here is little d over big D times n rev. Now n rev is the number of times the little circle is turning around compared to the big circle. So in this case, we've got this one's got 50 teeth and this one's got 20 teeth. So that n rev, the wheel ratio, the revolution ratio, is the number of revolutions we're going to have each time, is going to be 2.5. Our n rev is 2.5. So what we need to do is little d divided by big D. So little d, in this case, the little diameter is 170 times 2, right? Because we've got the radius here is 170. That's 170. So what we need is 2 of those is 340. So it's going to be 340 divided by 700. 700 times 2.5 because it's on the bottom, right? We put the n rev on the bottom. And the correct answer is 1.9. Okay, this question here, there wasn't a question. So the problem there was because there wasn't a question, we didn't have a, that question got ignored by the teacher. If I had been here to, during the reading time, I would have amended that to say, find the bending stress, the maximum bending stress of the question. Unfortunately, I wasn't here, so the question just got ignored, which is probably for the best because it's a question 20. It's a harder question. It's the only downside is that bending is unlikely to be in the test. Unfortunately, I think bending is really important, but bending hasn't been in the HSC for the last couple of years, and I hope that bending will come back. This question was actually harder than the question I would have written, which is, I guess, a good thing that it's been removed from the test because there was confusion there. But definitely, it's a question that I am unlikely to drop in the future. So we'll move along. It's too hard for me to go through that one without a whiteboard anyway. The idea is that the formula is the formula for our bending stress is, I could go through it quickly, is bending stress equals mi over I. So mi, in this case, is going to be the W. So first of all, we need to know the M. So the maximum bending moment in this situation is pretty simple. it's PL on 4, so it's going to be 8 times 6 divided by 4, which is going to be 12 kilonewton meters. That's what would have been our M is 12 kilonewton meters, or 12 times 10 to the 6, divided by, multiplied by Y, so we go with big Y, right, 154, 12 times 154, all divided by 106. So it's actually 12 times 10 to the 6 times 150 divided by 102 times 10 to the 6. The two 10 to the 6's cancel out, so that gives us our answer. That gives us our calculation. I can type it into my calculator now. Okay, we've got 12 times 154 all divided by 102. I can ignore the 10 to the 6's. So the answer will be 18.1. Okay. The next question. Okay. So I'll go over the wordy questions like this very, very quickly, but the answers I'm looking for here, because there's two bridges, it says both in big capital letters, so you have to talk about both bridges. What I would say is concrete arches, knowledge of the arch allowed us to use the structural properties of stone, which is that stone is good in compression and bad in tension. The arch gives us a way of using stone and dealing with stone's poor tensile strength. On the other hand, the suspension bridges, what we have is the knowledge of advanced materials. We have high quality steel, high quality concrete. We have very good production methods to ensure quality, and we also have things like finite element analysis and computer simulation that allows us to design much bigger projects with a greater confidence. That would be something along the lines of what I would have written there. Okay, the roles of structural engineers versus structural design engineers versus project management engineers. Designers design, project managers build. So what I would say is that the designers take into account forces and speak to stakeholders to find out design goals. Project managers are involved with things like maintaining budget, ensuring quality, and time safety constraints, those sorts of things. Okay. Explain one ethical issue. Okay, a few good answers. A lot of people talked about environmental pressures. People might talk about budgetary constraints, so that there's a pressure to bring in the project as cheaply as possible, and to build a project at a lower quality. The Engineers Australia tries to provide some objective standards so that we don't have a race to the bottom. That would be an example, but there's plenty of others. Okay, a lot of people spoke, and engineers enhance quality of life. A lot of people talked about, say, the NBN, the snowy hydro. People talked about planes. People spoke about a variety of things. So in this situation, the NBN provides us with high-speed internet, which helps allow for entertainment and business transactions or business services. That would be something I'd write about for NBN. Snowy Hydro is engineers helped to provide the Snowy Hydro project, which provided water source for agriculture and electrical production for consumer use. Something along those lines. Okay. Again, not a question I'm super excited to go through on a recording, but I will go through it super quickly. Okay, so what we need to find here, the question says find the reaction at joint A. So what we need to do is, first of all, we need to find, what we first want to do is we want to find the reaction E. Now the reason we want to find reaction E before we find reaction A is because this force, I just can't be bothered figuring out the angle there. Now I could, I'm sure it's within my abilities to figure out that angle, and if so, I could probably do this question in one go. But the problem is I don't know the angle of reaction A unless I use the three-force method. Now, I did not use the three-force method. I will go through how you can do the three-force method in class, but that is a trick, and this is not the first time that the HSC question has been something solvable using the three-force method. Most of you don't even know the three-fourths method, so I'm not going to labor that point, but I'm just going to say it can be worthwhile. Now, I use the example of saying it's like having a really specialized tool in your toolbox. Now, it costs money to have a specialized tool in your toolbox, and you might only use it once or twice a year. But the three-fourths method is a tool that it doesn't cost money, but it takes time to learn, and you might not use this tool very, very often. But it's still, if you're a high ability student, it might be worthwhile you learning, and it might be something to look at, even if a way just of checking your marks. But in this case, what we're going to do is we're just going to find reaction E, because we know the direction of reaction E. So to find reaction E first, we take moments about A. So taking moments about A, we have two other forces we need to worry about. We can ignore A, the reaction at A, because its perpendicular distance is 0. So anything times 0 is 0. We can ignore reaction A. So we have two forces. We have 20 kilonewtons times 4.33. Sorry, I'm going to say that again. 20 kilonewtons times 4.33. And that's going clockwise, so that's positive, minus, and we've got RE, which is an unknown, times 15, because that's going anti-clockwise. Okay. The answer we're going to get is 86.6 divided by 15. So RE is going to equal 5.77. Now that we know that the up force here is 5.77, what we can do is we can find out our comparisons of our forces. We know that we've got 5.77 going up, and we know that we've got 86% of 20. So 86% of 20. Look, I've got the answer is RAV equals 11.55. By the time we organize those two things, we get 11.55. That's the vertical component of RA. Now, we know the horizontal component of 20 is going to be 10, because that's 20 cos 30 is 10. Sorry, 20 sine 30 is 10. And if this is pushing 10 that way, RA has to be pushing 10 that way. So, what are our final answers? We're going to get RA equals the square root of 11.55 squared plus 10 squared, and which I haven't done, which was 15.28, and our theta is going to equal tan of 11.55 divided by 10, which is equal to 49 degrees in this direction. Okay. The next question is a trust question. Now, in the exam, they actually also asked you to know what FD was. FD is 0 because it's a zero force member. We can tell that it's a zero force member because this line here, CE, is a supplementary angle. So if that's a supplementary angle, there's just simply nowhere for this F force to go. If there was any force in this member here, it would just burst out. There's nothing to... The C and D have to balance each other because they're in opposition. So there's just nowhere for that extra force to go. If there was any force here at all, it would burst through the sides. So in that case, it means it's 0. Now, on the other side, it's not 0. And the reason why is because there's a force applied to that. And the force applied to that is what keeps the force in BF in check. There is an alternate way that where we have zero force members. If you ask me in class, I'm happy to go through it again. It's not something I would dedicate too much time and effort learning, but it can be something that saves you time if you can identify a zero force member quickly. Okay. The fact that half the class didn't even attempt the truss question, despite me saying at the half yearly that trusses are going to be absolutely in the trial and in the final exam, I just don't know what else I can do. Okay, like seriously, I don't know what else I can do. If people can tell me what I could do, let me know, and I will see if I can apply that. Okay, so what we know is, what I would do is I would cut through this section here. Now this will always be a lot clearer when I can draw on the board, but if I cut through this section, this BC to AF, if you cut through there, I'm going to have 3 members exposed, BC, BF, and AF. They're the 3 that I'm going to be worried about, BC, BF, AF. Now, if what I do, just for the sake of this, we can close. Yeah, that'll do. You know what I'm going to do? That's what I wanted, but I'll bring that back here and then go. I know that you're judging me that how many windows I have open, but anyway. So if we cut through here, if we cut through BC, BF, and AF, what we now have is we have 3 sections exposed. 1, 2, 3. 3 members that now have a cut. Now, what we can do is if we take points from F, we can eliminate the 2 we're not interested in. We're finding BC. We don't want BF. We don't want AF. There's a clue in the name that we don't. Point F is where we're going to measure from. If we measure from F, we can ignore this and we can ignore this. So we're going from point F, right? F, which happens to be there. And if we go with point F, we can ignore that one and that one. So now we have to measure our distances. So measuring from point F, we're going to have 3 forces. We're going to have BC, this 30, and this 25.5. So rotating, or taking those 3 forces, we ignore these ones because they're both 0. They're 0 because the perpendicular distance to F is 0. So anything multiplied by 0 is 0, so we can ignore them. 0, 0. This one here is going to be 25.5 times 15 divided by 2. So that's going clockwise, so it's positive. The next one is going to be 30 times 15 divided by 4. So that's going to be anti-clockwise, so it's minus 15 times 30 times 15 divided by 4. The next one is BC, which is unknown. BC times, again, 15 divided by 4. Why 15 divided by 4? Well, if I was to draw a line, now, don't plan on making too much of a habit of doing this, but if I was to show you this line here, that's the perpendicular distance that I'm interested in. Now, in that case there, we know that this is 7.5, or 15 divided by 4, and that is also a 30-60 triangle. Yeah? Let me see if I can find... Okay, didn't want to make a big habit of this, but we'll go with that. Okay. Okay, so we've got a 30-60 triangle. Whenever we have a 30-60 triangle, right? Whenever we have a 30-60 triangle, we know that the long side is twice as long as the short side. So if this long side is 7.5, this would have to be, if this long side is 7.5, this short side has to be 3.75. Or if this long side is 15 divided by 2, this short side will be 15 divided by 4. Okay. So I'll read through that again. Sum of the moments about F going clockwise equals 0, equals minus BC sine 30 times 15 divided by 4, 15 divided by 2. Sorry, I'll read that out again. Sum of the forces about F equals 0 equals minus BC, because BC is going, we assume that it's in tension. If it's if we assume it's in tension, it's going clockwise. Ooh. Yeah, for whatever reason, you know, I'll just come back and edit it later. Okay, So taking that formula, what we're going to get is setting clockwise as positive. We have sum of the forces about F equals 0, which is assuming that BC is in tension. In tension, it will be pulling from that node. If it's pulling out of the node, it's going clockwise relative, so it's going to be BC times 15 divided by 4 times plus 22.5 times 15 divided by 2 minus 30 times 15 divided by 4. When you get all that, you're going to find that BC equals 15, and because our answer is going to come out being negative, that means that we're in compression, because we made an assumption and our assumption ended up being wrong. And if our assumption ends up being wrong, then that means we're in compression. Question 22. This is continuing on, so we're still staying with structures, so that's why it's questions 22C. A portal frame structure is made of steel sections. Okay, identify a suitable carbon content. 3.3% carbon is the answer there. Identify a suitable fabrication method. That would be rolling. Rolling is the fabrication method. Okay, based on your answers above, draw a labeled microstructure of the steel. I am not going to do that here. I'll have to do that on board. Identify a suitable method of joining the sections on site. On site, so I'm happy with bolts and I'm happy with stick welding. Rivets, I think that's just no longer acceptable post World War II, and MIG welding is not suitable on site. So that's the answer. There's two options you can give there. Okay, finally over the page, question D of 22D. Structural timber beams are often laminated rather than being one solid piece of timber. Identify two structural advantages. Structural advantages means you can't say cost. What you can get away with is you can say readily available. I'd be willing to accept that, readily available. It's not really a structural advantage, but I'll let that go, whereas I won't let cost go. Okay, in beams for building structures. First of all, I would say defects, right? So it's easier to deal with defects when you have long sections. If we have a part of the timber's no good, we can just chop that off and just put in a new piece of timber in our laminate process. Also, we can talk about how we can set our grain structure to be beneficial. By alternating the grain structure, we get better strength properties. Also, we can talk about the resin. The resin actually makes the whole thing stronger. So that's the answers I would have given. Okay, corrosion has occurred where lead flashing has been installed in contact with a mild steel roof. So that's how steel roof has corroded, right? And we can't see the flashing because that's been removed for our photo. Okay, that's galvanic attack, right? Is the type of corrosion we have there. If you wrote dissimilar metals, I gave it to you. Okay, using the galvanic series now, zinc and aluminium, zinc, aluminium, and magnesium, right? ZAM, they're the three most reactive anodes. I remember it as A to Z anodes, A and Z, aluminium and zinc, A to Z are anodes, whereas CG is, is your cathodes. The C and the G even looks a bit like a C. Caius Appius Claudius, the blind Roman, he actually re-added the letter G back into the Roman alphabet. So C, for a long time, if your name was Gaius, like Julius Caesar, his name was Gaius Julius Caesar. Anyway, that was often spelt with a C because there was no G at the time. Anyway, so if that helps you to remember it, probably won't help you to remember it. Just CG. Cool gold is cathode. What, I don't know, something like that. Okay, I'm ranting now, so I'm going to stop. Which one is the cathode? Well, the cathode, so we've got mild steel and we've got lead. Which one's closer to the cathode side? Lead. Yep, so we've got our cool cat, the rad cat, he's got gold behind him because, anyway, lead. The lead didn't rust, it was the steel that rusted. Okay. Explain how hot tip galvanization protects steel members. Well, I would say there's 3 marks here. It's a lot of marks for this question. So first of all, you have to explain, which means cause and effect. So what you need to say is at the end, which protects the member, right? That's probably what you need. That's the last part of this mark. First of all, you'd say the steel is dipped into into molten zinc, which forms a protective layer for the structure. The zinc oxide forms a non-corrosive oxide layer, which protects the steel. That would be the answer I would give. Okay. With the aid of the label diagram, now I drew this on most of your exams. Again, I'm not going to draw that now. Will I? I can feel that I'm going to the... Okay, here's what I would draw. I would draw a line. Look at me drawing this. I can't believe I'm drawing this. And another line. This represents your cut, your scratch. And then I would draw something for water. That was not what I wanted. Okay, I'm moving on. What I would do is once I've drawn this, I'd say high O2 is the cathode, low O2 is the anode, so it's going to rust at the bottom of the crack. That's pretty much what you're going to write here. At the top of the crack, you have a high concentration of oxygen, which forms the cathode. The bottom, we have a low concentration of oxygen, which forms the anode. This creates a concentration cell, and it will rust at the anode. Okay, identify a suitable method for preventing corrosion of steel in a marine environment. Sacrificial anode. A block of zinc is probably what you want to go with there. Identify a suitable method for preventing corrosion in a pipeline of many kilometers. The answer there should be run a low current through the ICCP, impregnated cathodic current protection. That's the answer I'm looking for there. Some people use alternate materials, and that's not a bad answer, except that there's not really a suitable alternative. People talked about concrete. The problem is that the concrete still has steel in it, and that concrete gets cracks. You have a problem. The second option is you have someone said PVC, and the PVC is just not strong enough for a multi-kilometer pipeline. Okay, personal public transport. Identify one environmental advantage and one environmental disadvantage. Okay. If it runs on electricity is more efficient and it can be generated from renewables. A disadvantage, well, if it's not being made from renewables, it's still creating some pollution, and it's certainly producing more pollution than, it's less efficient than large transport. So it's less efficient than light rail or trains or something like that. Motors are used widely in engineering. Explain how motors convert electrical energy into mechanical energy. So I would say that when electrical energy is passed through a rotor, it produces a magnetic field which reacts with the magnetism of the stator. This causes the rotor to move, generating mechanical energy or kinetic energy. Okay, a vehicle travels at a constant velocity on a level road. The time taken for the journey is 60 seconds. Ignore that line. Thank you, Miss Mackenzie Hicks. I'm really glad that she was able to answer that for you guys. The power required to maintain this velocity is 300 kilowatts. Okay, we'll calculate the resistance to motion. Okay, so the formula for power is power equals FV. Force times velocity. The velocity is 1 kilometer divided by 60 seconds. So 1,000 divided by 60, because we're using SI units. 1,000 divided by 60, 1,000 divided by 60 times P will give us, okay. We want to find F. F equals P divided by V. So 300,000 times 1,000 divided by 60 gives us our answer. You have to convert it back to, that'll give us an answer in newtons, and so leave your answer in newtons. Okay, E, the Peak Tram, which is in Hong Kong, I wrote this after my holiday in Hong Kong, is, I I looked up the weight of a funicular car is 4,900 kilograms. Now you've got to remember to multiply that by 10 to get the weight. A lot of people got this wrong and they lost a mark because they did not multiply by gravity. Right, so you need to multiply by 10 or 9.8 if you're that way inclined to pull up a 20 degree incline. Determine the tension in the cable if the car to move the car up the incline if the coefficient of friction is 0.25. That's our mu. Now the way I like to remember this is T equals mg sine theta plus or minus, in this case plus, mg mu cos theta. How I remember is where the mu goes. The mu goes to make mucus. Mu like mu, cos like sine, cosine wave. Anyway, so when we multiply all that together, what are we going to get? Let me go to my answers. I've got to go a fair bit. Okay, where am I going to go? Okay, so it's mg sine 20 plus mg times 0.25 cos 20. Just check I said that again. Mg sine 20 plus mg 0.25 cos 20 gives us 176.5 times 10 to the 3 plus 115.1 times 10 to the 3. So our tension in newtons is going to be 282.600 is close enough. I used times 10 to the 3, so I'm happy to have the last two digits be 0, at least to my level of accuracy. Okay, this is a sprocket. Its teeth have been hardened. Justify a suitable hardening process. Now, a lot of people just said quenching and tempering. I wish that was the case. Unfortunately, we need the internal part to be quite tough, and if we quench it, that will be brittle. So we only want the teeth to be tough. So there's two answers: flame hardening or induction hardening. I'm happy with either of those. The reason why we do that is so that we have hard teeth that don't wear away, but we still have the toughness on the inside. That's 2 marks. Okay, why do we use both laminated and toughened glass in automobiles? This was answered really well. I was actually thinking about pulling this question right at the end, and I was going to replace it with injection molding, but instead I'm glad I left it in because most people did really answer this really well. So our front windows are laminated because they have to be strong and stay together in one shape. If we hit it, it gets hit by a projectile. Whereas the side windows, we want them to crush so that we can rescue people from the side windows. So that's the laminated. I should have mentioned the word laminated and toughened there, but I'm doing this